Okay, we're going to look at a few applications. First type is going to be the consecutive integers and or consecutive even, consecutive odd. As discussed in class, when you set up consecutive integers, that means one after the other, the setup will be x, x plus 1, x plus 2. When you go to consecutive even or consecutive odd integers, the setup will always be the x or the n and then the n plus 2. If x is even or n is even, the next even integer is 2 more. Likewise, that's true with odds. If n is odd, the next odd integer is 2 more. So the initial thing is to set it up correctly and then write the equation based on the description of the problem. So this first one, the product of two consecutive integers is 56. So here are your two integers, and with that you write the equation. Well, product implies multiplication, so it says if I multiply these two, I'm going to get 56. And so here is your equation. And then, of course, when you distribute, and then you've got to make a decision how you're going to solve this quadratic equation. This will easily factor, and I'm not going to go through it, but if you subtract 50, well, I will go through it. So if I go ahead and subtract the 56 and set it equal to 0, then this factors very easily. I'm going to get x plus 8, x minus 7 is equal to 0, multiplies to negative 56, adds to 1. That means x is equal to a negative 8, x is equal to a positive 7. So when they ask up here for the positive set of integers, well, I'm going to start with the x, which is the positive integer, which is 7. 1 more than 7 is 8. They do multiply to 56, and they differ by 1. And then the negative, well, negative 8 is the negative, but when I add 1 to a negative 8, that's actually a negative 7. These two multiply to be plus 56, so the problem is solved. Okay, so the only difference on this next problem is that when you set up your variables, your first odd integer is going to be x, your next odd integer, I'll just label it first and second, your second odd integer is going to be x plus 2. So when you multiply this to be equal to 99, you'll go ahead and solve it. And again, you can distribute and factor. I'm not going to go through all that, but you're going to get two answers. You're going to get x is equal to a 9 and x is equal to a negative 11. And you'll just go ahead and do the sequence of numbers in there. The next type of problem are these geometry problems. For example, the area of a rectangle is length times width. And the key in all of these is setting up your variables. So when you read this, you'll see that they do not say much about the width, but they do describe the length in terms of width. So that which they don't talk about much, call it, in this case, it makes sense to call it W, since it's the width, and the length is actually equal to W plus 6. So instead of using a variable L, I'm going to use the W plus 6. And what does it say? The length of the pen is 6 feet longer and the area is 187. So it means that I'm going to multiply the W times the W plus 6 because length times width, and it says it's going to be equal to 170, or excuse me, 187. So once again, you distribute. This is factorable, but you may not find it easy. This is very easily set up to complete the square also, right? You can divide 6 by 2 to get a 3. 3 squared is 9. You can add 9 to both sides, and you get a perfect square trinomial. And then take the square roots of both sides and so forth. Again, in the interest of time, I'm not going to go through it. Now, you are going to reject the negative answer because this involves length, which cannot be negative. So the width that comes out of this is going to be 11. And so thus, if your width is 11 and 11 plus 6, then your length is going to be 17. So the width is 11, length is 17. Same thing for the next problem. You got to set up your variables first. Okay, so if you read this, the width of a rectangle is 3 feet longer than 4 times its length. So the length they don't talk about at all. So I'll call it L for length. And the width can be described using the length. 3 feet longer, so I'm going to add 3 to what? 4 times its length. That would be 4L. And here it tells me that the area of the rectangle is 351. So again, the length times the width is equal to 351. When you distribute, and then you have to choose how to solve this. Personally, just looking at this does not easily set up the square. If I tried to factor it, I'd have to use the AC method because I would have to bring over this 351 to get it equal to 0. And that would be a really big number to factor. So at this point, I would choose to go ahead and use the quadratic formula, even though it may factor. I just don't want to spend the time doing it. And when you finish, you will discover that the actual length, this probably could have factored, is going to be equal to 9. Okay? And so if the length of the rectangle is 9 feet, then the width would be 39 feet, because it's what the width is 4 times the length, 4 times 9 plus 3, and you can see the answers right there is 39 feet. Again, so the problem setup is critical. I'm not going to go through the solution, as that's something that you should be able to do at this point. If we're solving an area problem with a triangle, here's the formula. Area of triangle is 1/2 the base times the height. So I've got this worked out already, but if you take a look at the description, then again, you got to set up your variables. And so they don't tell you much about the height, but they tell you that the base is 8 more than twice the height. So here would be the height and the base in the same variable h. Then you write the equation. The area 140 is equal to 1/2 base times height. And then a couple ways you could do this. We've always emphasized getting rid of fractions by multiplying by the LCD. So if you multiply both sides of this equation by 2, you would get this. But then you could see you could factor a 2 right back out and get it to this. Or you could have distributed the 1/2 through the parentheses, because the 8 and the 2 both divide by 2. And that would have been fine. That would have gotten you right to the same point. Once you're here, you decide what you want to do. This is set up easily for completing the square, which I did here just to illustrate it. But also note that if I bring the 140 over to one side, set it equal to 0, that this is easily factorable. Factors of 140 that differ by 40, 14, and 10. If it adds up to a plus 4, then a plus is going to be the 14. So when I solve this, I'm going to get x is equal to a negative 14. This should be h, to be consistent. So this is an h is negative 14, and h is equal to a 10. Well, I can't have a negative height. So this would be the correct answer for the height. So if that is the height here of 10, then 8 plus 2 times 10 would be 28. Another type of problem, use the Pythagorean theorem. For a right triangle, a squared plus b squared is equal to c squared. So if you look at the description of this, the long leg of a right triangle is 8 feet longer than the short leg. Okay, so they didn't tell you much about the short leg, so I'll call that x. The long leg is 8 more than the short side, which would be x plus 8. And they tell me the length of the hypotenuse, which is across from the 90-degree angle. So it doesn't matter which I label, but all I do now is just plug these into the Pythagorean theorem equation. And so x squared, the short leg, x plus 8 squared, the long leg, is equal to the hypotenuse squared, 2 times the square root of 26 squared. If I clean it up, x squared is self-explanatory. This is x plus 8 times x plus 8. So you FOIL, you get x squared plus 16x plus 64. When you square this, you distribute the exponent of 2 in. 2 squared is 4. Square root of 26 squared is 26. That multiplies to 104. I'll go ahead and get everything over to one side, set it equal to 0, factor out a 2. I can throw away the 2 because there's no x involved. It's just a number. And so this quickly simplifies to something that's easily factorable. Factors of negative 20 that add to 8, x plus 10, x minus 2 equals 0. X is equal to a negative 10, I reject it because that's a negative length. I'll keep the x plus 2. So when I substitute it back in, the short side is 2, the long side is 8 more, so it's 10. And of course, 2 times the square root of 26. Last type of problem are these projectile problems. On these, I think I cut off the instructions, but in these, they said round your answer to the nearest tenth or to the nearest hundredth. I don't know which. And so here you're going to take it all the way to a decimal number and not leave it in with a radical. And so for clarity, so the height, of course, given was 272, and they give us some information. The initial velocity of 150 feet is the coefficient of the t term. This minus 16t squared is the kind of the standard in these, and then the initial height is going to be 0 because it was launched from the ground. So this represents being launched from the ground. That can kind of be ignored. This is the initial velocity. This is the height that we're interested in, and now we solve it for the time that it would achieve that. So obviously this is a quadratic equation. So if you get everything over to one side to get it in standard form, and this would not easily be factorable, not conducive to completing the square, so I would immediately go to the quadratic formula. Here's your A, there's your B, there's your C. I'm not going to do it all, but if you punch it in correctly, you're going to see that it hits, and again, this thing is being launched from the ground, right? And we're interested when it hits 272 feet. Well, that happens twice, on the way up and on the way down. So it wouldn't be unusual to have two answers. In this case, we do. So it's going to hit it on the way up at about, one of your answers will be 2.5 seconds if you're rounding it to the nearest tenth. And on the way down, it will hit at approximately 6.9 seconds. Again, just plug it into the quadratic formula. And so this last question is really no different, except the initial velocity of 90 feet is different. Instead of from the ground, it says that it's being initially thrown from a height of 4 feet. So this is the initial height. This is the initial velocity. This is always in these problems. That's the force of gravity. And we're interested, when will it be at 99 feet? Okay, so let's put this into standard form. So if I subtract 99 from both sides, so if you take a look at 4 minus 99, you will get minus 95. And again, not conducive really for anything other than the quadratic formula. So if you plug your A, your B, and your C into the quadratic formula, work it through your calculator. Again, the baseball is gonna go through 99 feet twice, on the way up, on the way down. On the way up, an answer you should get is about at 1.4 seconds, and on the way down, somewhere around 4.2 seconds. Again, using the quadratic formula. So here, the key is setting up an equation, quadratic equation, and then in all these problems, determine which is the most efficient and easiest method to solve it. Okay? Good luck.